Okay, hi everyone. So today we're going to have some Python and then we're going to do midpoint presentations. So I hope you guys are excited for that because you'll get to see what other groups are working on and you get to impress other people with your progress, hopefully. Okay, so first let's take a few minutes and do the attendance quiz. Okay, if you guys are done with that, we can move on. Okay, so homework 5 will be released tonight, so a little bit after midnight probably, and it's going to be due next Tuesday at 11:59 p.m. It's going to cover some more linked list stuff and stacks and queues, which is what we're going over today. Okay, once again, office hours, we have them Monday, Wednesday, and Thursday, so I think this is one of the first weeks where you guys actually probably should take advantage of Monday office hours because you have homework due Tuesday. So if you want to beat the crowds, come in tomorrow or Thursday, but Monday's definitely an option if you're having some last minute troubles. I know a lot of you have been having problems pushing to GitHub, so if you want help with that, definitely come in on Monday. Okay, midterm grading, so you guys got your midterm grades. So there's been quite a few comments about these. So we've added grading categories, so you can see how exactly you were graded and what for. If you have questions about these, you can go ahead and reach out to your interviewer to find out more about why you received those grades. But that said, once you ask, please don't bother them anymore. So this is not very subjective. The grades were graded on a pretty specific scale. So there's not much you can really argue against. But that said, you can definitely reach out to find out why you got the score you did. Okay, and then we want a little bit of hackathon feedback. So can somebody tell me what they thought of it? Yeah.
It was missing coffee.
Coffee, I see. But it only went to 9 o'clock. I feel like that's not very late.
Coffee's great all the time.
I see. Okay. Does anybody have any other comments? Yeah.
Cookies were really good.
Okay. All right. And does anybody have any improvements? So things that you think could have gone better? Because we're always looking to make things better for next semester. Did you guys like this one better than the last one we had? Just raise your hand if you like this one better. Okay. Alright, so we're going to move on to Python. Today we're covering stacks and queues. So raise your hand if you know what stacks and queues are. I see literally one person with their hand raised, and I feel like that's not true. It's okay if you don't, but okay, more people on staff are raising their hand. Alright, but yeah, so today you're going to learn what exactly stacks and queues are all about. Give me a sec. Alright, can everybody see that? Does anybody need it to be bigger? There we go. Alright, so today we're going to be talking about stacks and queues. So a few of you raised your hands. Can anybody explain to me, and I'm going to like hide this for a second so you can't read it. Can anybody explain to me what the difference between a stack and a queue is, or what exactly stacks and queues are? I know some of you had your hands raised. Okay, yeah.
Stack is a resizable array that you can add things towards, and then you can pop things from it. And then the thing you pop is the tail of the array.
Okay, so you're kind of hitting on like some related ideas. Basically, a stack is, I'll just show you. It's a little hard to explain. Okay, so basically, a stack is like if you have, let's say you have like a Pringle can, right? So let's say we have a can, right? And we put Pringles in it. So keep putting Pringles in, and then we want to take them out, right? So when we take something out, it's the last one that we put in, right? So that's something called LIFO, so it's last in, first out. So the way that you put things into the structure is, so you put things in, and then when you take them out from the top. So in my mind, I always picture it like, kind of like some sort of container, so it's like this. Can anybody see that? The markers are like really bad. But I picture it like this, right? So we put items in, we have item 1, right? And then I want to put another one in, so that's item 2, right? And then I keep putting them in like that, right? But then when I take them out, which one comes out first? Yeah.
3.
Yeah, right. It's easy, right? Okay, so 3 comes out first, right? Because they're kind of all stacked in there. You can't exactly just reach in and grab anyone you want, right? Okay, so if we look here, we're going to talk about some methods that are commonly used with stacks. So pushing is adding an element to the top of the stack. So that's like putting something in the container or putting something in the can, right? Popping removes the top of the stack. So if we put a ton of stuff in, it's going to be the last thing that we put in. And then peek is just a function that lets us look at the top of the stack, but it doesn't take off the top of the stack. So if you look here, yeah, you want to note like a few important things. So popping removes and returns it. Peek just returns it without removing it. Okay, does anybody have any questions about that? Okay. And so the way that we're going to do this in this class, and you'll probably do this if you go on to take 225, is with a linked list. So that's a good way to represent this. And yeah, so basically this just goes on to say that like it's important for interviews. So this is a really common thing. If you go for an interview, especially if you are like a freshman and you do like one of the like introductory programs like Explore, like Google EP, you'll probably get questions like this. So you know how to implement things with stacks and queues. It's pretty important. And also when you take 233 and you learn about assembly, you learn about like the actual stack. So in memory. So these are really important concepts to understand no matter how they're implemented. Just conceptually, it's good to know. Okay, so now that we've learned about stacks, can anybody tell me what they think a queue is? Yeah.
First in, first out.
Yeah, so basically, yeah, that's exactly what it is. So can anybody give me like a real life example of a queue? Yeah.
Waiting in line for coffee.
Exactly. So like, you know, like in the UK, people say queue instead of line, right? So it's like, basically, if you're the first person there, you're the first person who gets whatever, right? Like if you go to Starbucks and you're the first person in line, you're the first person who gets served, right? Like people don't jump in front of you. It's not like with a stack where the last person just gets to get served first, right? So queues are very much, you just push things in and they move through and we take the first one off, right? So here we talk about enqueuing and dequeuing. So when you unqueue something, you add it to the back of the queue, right? So if we're all waiting in line, you go to the back of the queue. Dequeuing is when we take an element off, right? So we're going to take an element from the front and then we're going to return it. So you'll see with these, the runtime is constant, as it was with the stack for a linked list. And then, yeah, so with a linked list, we use pointers, and you guys work with this on the last homework. We use pointers to maintain the head and tail, so where we are in the queue or where we are in the stack. Okay, does anybody have any questions at this point? It's okay if you like don't understand this right away. I think like it's a little bit tricky in the beginning, but the more you work with it, the more intuitive it becomes. All right, so now we see here, we're gonna actually make, I think this one, okay, so this is just the node class. So we're making a node with data, and it has a next pointer, right? Right here. Okay, and then this is just for printing it. So you guys should be familiar with this. I think we used this last week, or the week before actually. Yeah, so let's go ahead and run this. Okay. So now, we're gonna go ahead and make the stack. Oh shoot, I skipped a section, that's why it's confusing. Here's the stack class. So here we have the init function. So we have a pointer called top that's going to point to the top of the stack. And then we have the functions that we talked about, right? So these give us our basic stack functionalities. So we have push, pop, and peek, right? Okay. So let's look here and let's see what's going on. So with push, that's when we're adding something to the top of the stack, right? So this first line here says, if our stack is empty, then we want to make a new node, right? So we make a new node and we put it in the stack. And the way we do that is we set the top pointer to point to that node, right? The top pointer indicates what's at the top of the stack. If the stack isn't empty and we already have things in it, then that top pointer is already pointing to something, right? So what we're going to do is we're going to make a new node. That's the thing that we're pushing. We're going to set its next to self.top. So next is a pointer that points to the next node in the linked list, right? So next is going to point to what used to be the top of the stack, right? And then we're going to reset the top pointer to be temp, which was our new data element. So that can be a little bit confusing. Like, that's something that you do in 225. I remember when I did like 225 MPs, I was a little bit confused about like how pointers work and like how exactly this is all happening, especially because you've got a bunch of temps and you're reassigning things. Does anybody have any questions? It's totally okay to have questions about this. Like, don't feel intimidated if like a few people in this room know what they're doing, because like I certainly didn't know what I was doing when I learned this, and so it's okay to ask. Yeah.
So peek, you look at it, but don't return it, and pop, you do.
So peek, you look at it and you return it, right? We just want to see what's there. Pop, you look at it, you return it, and you take it off the stack. Okay, anybody else? Does everybody understand what's going on here? Like, actually understand this? Like, you could explain this to somebody else without looking at it. Okay. Okay, so now we move on to pop, right? So we're trying to take something off. So once again, we have this part here. So if there's nothing in the stack, we can't pop something, right? We just have to leave it be. So we just return none. But if there is something in the stack, then we have to take it off, right? So because we want to return it, we go ahead and save it, right? So self.top is the pointer to the top of the stack. So we save that in temp. And then what we do is we set top equal to temp next, right? So what that's saying is, okay, we have the top node, and now we're setting top to the node right below it, right? Because that's going to be our new top once we pop off the top of the stack, right? Okay, and then we return the data at temp, which was the old top, right? So essentially what's happening here is the link that the node that was the top is just getting like unlinked from the other ones. The pointers are removed, so it doesn't, it's not in the stack anymore. So that's a little bit tricky to think about. I think this is like it's more understandable in like C++ when you're actually working with memory and stuff, because you're kind of like, well, what happened to the top one though? Like, we didn't get rid of it. But it's, I don't know, if you do C and C++ stuff, I guess it's more intuitive. But yeah, does everyone understand this concept here? Some people look confused. Does anybody have any questions? Okay. Okay, we'll post these, so you guys can take a look if you want. Yeah, and then we have peek, right? So peek is super easy. This is just like pop, except we don't get rid of it, right? So again, if there's nothing there, if the top pointer is none, it's not pointing to anything, then we just return none, right? Otherwise, we just return whatever's at the top, that data there. Okay. So now let's kind of see this in action. I'm going to run this. So we created a new stack, and then we pushed these numbers on, right? So somebody tell me what's going to print when I print S. Yeah.
1, 2, 3, 4.
Let's see. Okay, so not quite, right? So you're kind of on the right track, but what's happening is 1, 2, 3, 4. I mean, you might have been describing in the opposite order, and I'm just visualizing it differently, but if we go from the bottom to the top, what's happening, and when you see the linked list implementation, the last node in the list is the first thing that we pushed. So we push this, and then we push 2, then 3, then 4. So the head of the list and the top pointer is 4, right? I would have had to do these in the opposite order to get 1, 2, 3, 4. Okay, now what's gonna happen when we do pop? Someone just shout it out. What are we gonna get? Well, we'll wait till we print it. Let me just run it. Oh, it printed, okay. Okay, what are we gonna get when we run peak? Okay, I heard 4. Any other guesses? I see 3, okay. Yeah, it's 3, right? Because we took off 4. So 4 is not in the list anymore. And so when we print S, you can see that, right? So we got rid of 4, and now we just have 3, 2, and 1. Okay, so we're done with talking about stacks for now. Does anybody have any questions about stacks? We did go through this a bit fast, and it's a pretty important concept. So if anybody has any questions, I recommend asking them now, because other people have the same ones. Yeah?
Do you have a short example of where you might implement this?
Where you might implement this. Okay, so I'm trying to think of an example that like makes. Are you a CS major?
No.
Okay. So one example where I've used stacks before is so in 225, which I'm also a CA for. So I've helped people with this a lot. But when you take an image and you want to, let's say, color it, like you have some sort of shape and you want to color it, right? We do there's a certain algorithm that uses a stack to put each pixel in and then take it out and process it. So that sounds like a complicated example if you don't know more about like algorithms. There's a lot of staff here, does anybody have a good example of a stack example? Like, a good example is just memory, like things get pushed onto the stack and then they get taken off, and so when you get a stack overflow, that's what that is. There's too many things on the stack. But yeah, does anybody have a good example? I can only think of like complicated examples. Silence. Okay. Do you want like a CS example, or do you want like a real world example? Like an analogy?
I was looking just for like an actual application, but that's okay if you don't have one on hand.
Oh yeah, Connor, what?
I mean, you could talk about like algorithms like DFS that require
Yeah.
a stack.
That's what I was trying to hint at, but like you might not know what that is. So when you do searches, and we're looking at like, so if we look at a group of things like pixels, right? So we're looking at an image, we have a bunch of pixels. One way you could change all the colors is you could put them in a stack and then take them out. And then that's called a depth first search, because you're going all the way through, the first one ends up at the bottom and then you start taking them out. So it's a little bit complicated. If you're interested in that, I would suggest Googling it. I could post a link on Piazza, just so you can see like a visualization of that, because I feel like that's a really good example of how stacks and queues are different, because you can write the same algorithm and implement it with a stack and a queue, and you get either a DFS or a BFS. So yeah, I can post something on Piazza about that. Yeah.
I have a non-CS example.
Okay.
Of a stack. So if you're putting dishes in the sink, you're just gonna keep piling them on top of each other, and then you start feeding them,
Yeah. Yeah, exactly. So that's a really good analogy. So like dishes in a sink. So like you keep piling them up and your roommates never wash them, so they just sit there. And then when you go to wash them, you have to start with the first one, right? Okay. All right, so let's move on to queues. So with the queue, we've got pointers to the front and to the back, right? Okay, and you should, yeah. All right, okay, so we've got the function onQueue, right? So when we onQueue something, we need to do a couple of things. First, we need to check if the front is empty, right? So if our stack is empty, we have to make a new node, right? Because we don't have to deal with anything being there. We just make the new node and we put it in the stack. So we set the front pointer to that node and we set the back pointer to the node, right? Because if we have one node in our stack, or sorry, I said stack, queue. If we have one node in our queue, it's both the front and the back, right? So both of those pointers need to point there. However, if we do have stuff in the queue, we still make a new node, right here. But now what we're gonna do is we have to put it in the back, right? So we take the node that back points to, we take its next pointer and we point it to our new node. And then we set our new node to be the back. Does that make sense? It's confusing when you're saying it in words. If you draw it out, it makes a lot more sense. So if you like go home and just like ponder this and like draw it on a piece of paper, this will make a lot more sense to you with like pointers and stuff. But that's essentially what's going on, right? So we're adding something to the queue, and then we're going to reset the pointers, right? So we don't do anything with front because it's not affecting front. There's something already there. We just take the back pointer and we move it to the new node. Okay, so when we dig queue, if there's nothing there, we just return none, right? Because we can't remove anything from an empty queue. However, if there's something there, what we have to do is we have to return it, right? So first we're going to save it, just for the sake of being able to return it. So we save it in temp. And then what we do is we set the front pointer to temp's next, right? Because we're taking away the front thing, and the thing behind it in the queue is now the front, right? So we set the front pointer to what front's next was, right? Okay. And then we just return it. So what's easy about this is that all you have to do is you just take off the front of the queue, and then you just move the pointer to the whatever was behind it, right? So it's pretty simple, but it can be hard to visualize. Does anybody want me to like draw it out, or does anybody want further explanation on this? Because I feel it's a bit confusing talking about pointers like this until you actually work with them yourself. So does anybody have any questions? Nope? Okay. Alright, so I suggest that you take a look at these. These will be posted, and try to understand, really understand what's going on. Especially if you plan on ever like having a job in CS or something, this will definitely come up in an interview. This is just something that's really important to understand. And it's fun to understand, so you should. Okay, so we're gonna make our queue now. Somebody tell me what you think it's gonna print. I feel like we haven't heard from the left side of the room that much. I'm just gonna wait until somebody answers.
1, 2, 3, 4.
Okay. That was like either an educated guess or you really know what you're doing, because it's true. So, basically, yeah, it's 1, 2, 3, 4, right? It's exactly like if you were standing in line, right? So, person 1 comes up to the cashier, then person 2, then person 3, then person 4, right? So the end of the line is at 4, and the beginning of the line is at 1. So when we day queue, what are we gonna get? 1, okay. Exactly, right? Because we're just taking off the front. Okay. And then what does our queue look like now? Exactly, yeah. It's just gonna be the rest of it, like the 1 is taken away and the rest is there. Okay, so we're almost done here. So, basically linked lists are one way to implement this, since we already taught you how to do them and they're really valuable to know. We're going to have you implement stacks and queues with those. But also Python lists have functions that let you do this too. So it's a little bit weird, but it works. So if you see here, they make a new list, and then they use these functions here, right? So we're making a stack list. It's a list, but it's a stack, right? And so when we have these functions append here, and we run this, we get what a stack would act like, right, when we add these. So we appended 1, 2, and then 3, right? And so, yeah, that's what we get. So when we pop it, so basically this here, it's just acting like a list, right? So it just put 1, 2, and 3 in there. There's nothing special about that. It's just how you would append to any list, right? But when we pop it, we're gonna get 3, right? Because 3 was the last thing put in there. So the point here is that these are just not random. These are just typical list operations. This is nothing special, but Python has functions that interact with the list as if it is a stack or as if it is a queue, right? So when we pop it, we get 3, and it understands that function. And when we print this, we have 1 and 2 left, which makes sense, right? So what's a bit confusing here is when we printed our linked list, you saw it in the proper order, right? And here, it's obviously, it's not in the same order as it was with the linked list, but that's because it's in a list, it's in an actual Python list format. You just have to remember that it's a stack. So now we're going to do the same thing with a list as a queue. So when we print this, we get the same thing, right? 1, 2, 3 in a list. And now we're going to pop. And we get 1, right? So we took off the front of the queue. So it's the same thing. It's like the same thing that you guys already know. And then when we print it, we get that. Yeah.
So can you pop anywhere in the list with that formatting?
Actually, I haven't tried this. Let me see. Oh, it's not even. Yep, it looks like it. Okay, so yeah, okay, so this is like one last thing here. We're running a bit low on time, so we'll cover this quickly. But there's another thing called day queue. So using a list is not super efficient, so Python kind of optimized this, and we have something called day queue, so we can import that. So basically, you can see here, we're setting variable q equal to this, and then we append a bunch of things, right? So when we print this, we get 1, 2, 3, right? Okay. Now, when we run this function, pop left, we get 1, right? And then when we print this, 1 is gone. So that's just a more efficient way of doing it that you should keep in mind. But yeah. And so one last thing to talk about is, yeah, these are really popular with interviews. And there's a lot of really fun things you can do with them. So like one classic example is if you're given 2 stacks, how do you implement a queue? And that's super fun to do. So it's easy once you like know how to do it, but it's fun to figure out when you're like just learning about these. So I think you do that in 225. I think that's like part of one of the labs or the MPs. So if you go on to take that, yeah, you'll get to do that, which is fun. Okay, so that's it for Python. We're gonna start having the first groups come up, so just wait a sec and I'm gonna get the order of the groups. Okay, so we're just gonna go in the order listed here. So if you're one of the next, so we're gonna start out with crypto, and then if you're the next one, just prepare to come up here. If you have slides, just tell me if you sent them to me or if you need to connect your computer to the HDMI. But yeah. Does anybody have any questions? Oh, I saw a hand over there. Yeah. I'm sorry, I can't really hear you, but are they on Google Drive or are they on like?
Yeah.
Okay, yeah, that should be fine. I mean, it's easier if you just send them to me because then I can just open them from my account.
Okay.
Okay, yeah.
What does it mean if your project is in that?
Don't worry about it. I actually don't remember. This is just something we use for logistics, so I'm just using it for this order. Anybody else? We're gonna go ahead and start then. Okay, so cryptocurrency algorithm, if you guys can come up here.
And
I'll leave the mic up here so you guys can use this.
Do you have any HDMI? I'll let you guys know. Is it connected? You need to get this. Is that it?
Up on the screen is some of our code on your left, and then over on the right, we'll run a simulation, and we'll talk about what that simulation does. So everyone will start with.
Alright, so I'm working currently with these two other guys on the front end of the program. We're planning to use Django for our database or front end back end connection. And to deploy the app, we're going to use something called Google App Engine and Google Cloud Platform. Currently it's not deployable at the moment, but we're working on it. That's all I have.
Like he said, we were using the Django framework, which we could use to connect using Python code and deploy it onto a web page. So one of the struggles that we found and we were having right now is really being able to connect or pass data inputted on the HTML page back into our own Python code and into the algorithms that we developed in the back end. And we would have liked to have a working web page so that you can really see how the algorithms work on the presentation slide, on the presentation. But we weren't able to get that at this moment, but we're going to continue to work on that going forward.
Yeah, like we said, our main focus right now is just getting the web page working with the algorithm that we have right now. Connor and Peter were working on the algorithm and figuring out ways to get the exact price and determine what profit exactly means. And I'll let Peter elaborate on that.
Sure. So yeah, what this simulation is doing is simulating trades between two exchanges where there's a discrepancy in the price of a currency. So we did some work to figure out how we can define that price discrepancy by looking at the bid on one exchange and the ask on one exchange and try to take advantage of the difference. So going forward, this is only going between two exchanges, so we have a lot of work to do in terms of making it more realistic because we have to incorporate fees between exchanges and actually holding money on certain exchanges and how we're going to facilitate transferring a currency from one exchange to another because there's fees involved with that too. So we definitely have work to do in terms of making it more realistic, and we'd also like to put in, expand on the visuals because we were able to output some graphs which show how profit is being made as the number of trades continues. And I think the last graph we showed a little histogram which shows the profit of each trade. So we want to make these a little bit more accurate so that they display a more accurate picture of what's going on.
So I spent a decent bit of time working on the actual code to run the simulation, which will integrate into hopefully something nicer than just a little command line script. But as you can see, what we do is run the algorithm currently. It takes command line arguments, or it has a little interactive feature, and it uses an API called CCXT, which allows us to interact with all the different cryptocurrency exchange markets. We poll them for their prices. We use the differences in prices to simulate making trades, which we keep track of internally. That way we don't actually have to have real money at stake while we're working on the algorithm. And then finally we output some useful statistics such as profit, number of trades, how those trades were made, and also make some different images.
Okay, and the final product should be, so if we were to open up a web page, which shouldn't just be on our local host, it should be just accessible by any of your computers. The ideal ending would be for you to input which exchanges you would like to do, how much money you're putting in, and it would give you visualizations like these, but not just in JPEG form. It would give it to you real time. And that's just our goal in general.
Does anybody have any questions about how the algorithm used cryptocurrency exchanges, making a simulation in Python? Thank you.
The next group is distributed web hosting, so if you guys can come up here, and then I-access adjustment, if you guys could be ready after them.
Oh, this is what we give us.
So those celebrate, I can't get their. Yeah, so you'll just share slides. They will have to do it for the developer and actually, yeah, they'll be fine. You'll get multiple projects and multiple people.
Oh, you realize we're using the unit test, right?
Yeah.
Yeah, you realize we're using the unit test, so we need fresh stack objects per function.
So that's what like a real life. The way these tests are designed, the camera is this camera control. I'm gonna make this over live and people just access it out.
No, but like the stack object isn't shared between
I can
unit
show
tests.
people those pictures, you can add it picture and then I can show that. Only people who want to do it inside.
What? Like unit test by default, like whatever you make per test case is not preserved outside of that test case. Is what one.
So our project is distributed web hosting, and so pretty much the idea is you can host a web page from different servers, and the thing is it'll access the parts of the web page from those different servers and combine them together to display it. So you're not always relying on just one server for all your HTML.
So basically, we're kind of getting rid of like the directory server here, and basically we're just trying to make it all like where the servers are communicating, and so that's what we're doing here on the other picture. And as you can see, like if you need to reach another node, if you like know how like a binary search works, it kind of cuts in half, so it just goes through faster. So if one of the nodes stops working, it will just jump to the next one, and it should be able to find like the rest of the whatever it needs on all the other servers. And we're basically just trying to work with nodes using this like peer-to-peer sort of method.
So, what I'm working on is trying to implement using what's called the Chord protocol in Python to try to get computers to communicate with each other so that they can make connections indirectly. What Iridina just described can be a little bit confusing. I know it confused me a lot, it still does, but she said it very nicely when it's essentially like using a binary search to find your node. But what exactly are you searching through? Well, this is something called a distributed hash table. So we give each computer addresses, and those are in numerical order. So we can just continue saying like, is this one lower than the one that I'm looking for? So let's go on. And the reason why it's distributed, and the reason why it helps to be distributed, is if you look at the normal server, you have a server, even in a peer-to-peer file transfer, something like a torrenting service, you normally still have a directory where you access and you get addresses and you say, I'm looking for a file over here, and the directory says, oh, this person has that file, go over there, and then they'll connect you two together, and then you can do the file transfer, but you still need a central system. And we're trying to take out that kind of central system, so we have redundancy, safety, and the ability for many nodes to join and leave the network. So to set this up, you create something called a finger table, which is just like a skeleton of the network. So you just have a few addresses to use, and because each node has just a few addresses, in the end they can all make connections with each other. So for example, this node A that you see, because there's 16 nodes on here, we only really need 4 addresses in order to make it all the way across the group. The ring is just a visualization. It doesn't actually signify a cycle or a circular geometry in any way. But yeah, as you can see, we can go from node A to B just by using going to the closest address we have, asking that node, what address do you have for B? That node says, I don't know. It's not a power of 2 away, so it doesn't know. So it just goes as close as it can. And then that one that you see close to B says, yeah, I have the address for B, and then it goes over there. And then you can connect A and B. Yeah, we'll talk a little bit about what we're actually going to do with this network now.
All right. I think some of you might have heard Flask. So basically, what I'm doing is I have built a Flask server that can save files users posted, and I have already tried to be able to read those files by bytes. So and what Arena and I'm trying to work on is we are going to split those files into chunks. That's an important thing in our project.
I think we had a demo, but I don't think we're able to.
We're just having. Alright, so it was just a resolution thing. It's really low right now. Oh, wait, I did not think so. set up a system with yeah, so we set up a system with 8 nodes to give you a basic demonstration of what these do. This looks not great because we don't have a front end yet. That is something we're working on. But this is to give you an example of why what you might see the nodes do. So first we need to get each one a name. And at this point we're just giving them simple names like numbers that are sequential. One of our future developments is to 0, 1, 2, 3, 4, 5, is to give them addresses which are hashed, so they're a little bit more secure, and also they don't have to be sequential. But if you look, when we create a node, we can see it sets up this finger table for us, and because we have 8 total nodes, we only need 3 addresses, or log base 2 of 8. And if we want to go from node 0 to node 7, let's ask for that. You can see node 0 first contacted node, this one, which was, what was this one, 4? Because that's the closest address to 8 it had, or 7 it had, right? And then 4 directed it to 6, and then 6 directed it to 7, and then I finally found it and made a connection. So this is what we're going to be building from this point on. Does anybody have any questions or comments?
Okay, okay, if I access adjustment can come up. Do you have, yeah, let's this. It's on the system. If you go to display. Just go to go back. So go to displays. Just try switching. Like full left and mouse over. Oh yeah, this one. There you go.
Alright, so what we're trying to do with our project, the I-axis adjustment, is we're trying to implement the Hirschberg test, which is a test that is used to diagnose strabismus. Basically, what you do is you shine a light into someone's eyes, and you look for this reflection, and it's supposed to be in the center of the pupil, actually a bit nasal to the center of the pupil, but as you can see here, this person has strabismus because it's not in the center, so we're implementing something that it will shine a light into their eyes, and using computer vision we can detect if they have strabismus.
Okay, so we're basically using OpenCV for computer vision,
And Peter here has set up a web server where you can access the web application, and you just have to send a picture to our server and we'll tell you the degree. Currently what we have working is just eye detection code. So I'll make the server live and all of you can access it, and if you want to, you can send us your pictures and we'll tell you where your eye is. Does that sound cool, guys? Okay, just a sec. Okay, so the server is live on if you go to that site, okay, so you have to implement another thing because our server is not secure. And only Macs with Safaris will be able to like send us data.
Alright. So I'm here as this dude here has already talked about my job is to implement the web frontend and the backend using Flask. Our frontend was done using Angular 4 and CSS was done using Bootstrap. So if you have a Mac and Safari and you have Safari and I will walk you through how to. Yeah. And now we are walking you through how to enable camera access from insecure sites in Safari. First, go to Safari Preferences, then go to Advanced, and then have Show Develop menu in menu bar enable.
It'll be on the bottom.
Yeah. Yeah.
Then just go and develop.
And then WebRTC, allow media capture on insecure sites. And then yeah, and then I will give a demo on sending my eyes to the server for processing.
So it got the eye, but because the picture wasn't straight enough, it didn't get everything really well. But yeah, that's what we're trying to implement. Does anybody else want to send me a picture? Maybe not.
Yeah. Maybe not.
Come on, guys. One picture.
Yeah, okay.
So our end of semester goal is basically to implement so first we have to detect the pupil inside the eye, and then we have to detect the white dot inside the pupil. So the next goal is to go through that process and then implement a mathematical formula to find out the degree relative to both the eyes. So I think that's about it.
Okay, if Galaxian can come up here, and then high frequency trading, you're next.
So a lot of people send me, do you have any first one? I got like at least 20 pictures. But yeah, I couldn't make 20 pictures. That's sad. Very small pictures. It's all possible. Yeah, that's where it goes. You want me to send you pictures?
You don't want to come back there?
Oh, yeah.
Or we could just do a shot.
Alright, so we're the Galaxian team, and our project is kind of twofold. The first part is we're making a text adventure game engine. So the idea being that you could, like, you know, with knowing how to use the tools, you can make kind of any text adventure game within, and, you know, even add your own functionality if you felt the need to. And the second part is we're going to actually make a game with said engine. Here is an example of, like, you know, this is just from the text adventure game Zork, if you don't have any idea how those games work. The arrow is just what you input, and then it, like, reflects that on the world. So, like, move rug goes into detail about what happens and how the world has changed as a result. And that's basically how the whole game works. And if you look down here also, if you type in what is a grue, it'll elaborate on what a grue is, which it's like a type of monster, as you can see.
Yeah, so our goal is just have like an easy to use architecture, so you can understand, so that you can not only play our game, but produce the assets to make your own game. And then once we have that, we'll just make our own game, and it's fun.
Yeah, our main idea for when we say easy to use architecture is, like, we're doing our best to condense things into just a few functions that you'd use for a lot of the game's aspects. Like movement, we have solidly defined, just north, south, east, and west. And then there's also a create and delete inputs that you can use to create items and add context to the world involved.
Okay, so for the current state of the project so far, so what we have is the architecture of the engine itself is in place, so it's in a very rudimentary form where a very, very simple game of being able to move a player from a simple set of coordinates is in place. We can create items, and then, as I said, just a very simple world as defined on a 2D coordinate system, and it can be populated in that sense. So we're currently working towards adding more commands besides movement. So as you saw in the screenshot of, like, what you would expect from a text adventure, the ability to interact with items, to use items, and apply them in some way to the world around you. And going hand in hand with that is developing a better text parser. So the way that text is currently parsed is we have a very simple list of key commands. So for example, if you wanted to move north, east, south, or west, as defined in our 2D grid system, it will just look into the text input and see if it sees one of those keywords in it. So what I'm working on is trying to develop a text parser that can recognize that, but also pull a number of tokens after the keyword, so it can then determine, okay, if it said, for example, use what? So if you wanted to use an item, does it match an item that you currently have or is in your vicinity? So that's a little trickier than it sounds, actually a lot trickier than it sounds, and that's one of the things that we hope to have by the end of the project.
This is just how our engine works. So there's the game class, which is just basically a while loop.
that calls the update class. What update does, it keeps track of the player, so how the player is changing, the world, how the world is changing, picking up stuff, dropping stuff, and then all the game logic. And input is where the user commands, we make sure they're like ready to be used by update, that update can understand them. So we check for validity, what we have now, like, takes it in and makes it like all uppercase, we have to change that. Anyway, and then output, it just displays all of that updated game state to the player. So just text and description of rooms, items. And then like you, that would use the game engine to make your own game, you work with the assets folder. Because that's where you have like things specific to like a genre or like to your own like storyline. So like the players, like what do you want the player class to be like keep track of? So like maybe you need like health bar, like ours like you won't need that. So yeah. This is just a diagram that illustrates the architecture.
So now we'll just go into like what we're currently working on, each of us in the project. My current role is like to, so each item is going to have a couple different descriptions attached to it. One is a description of the item itself, the other is its place in the world. So like say you go into a new room, you use the look command, and that'll give you a description of the room you're in. So let's say, you know, the normal description of the room would be, you're in a dimly lit room, right? But say there's a sword in the room. The sword will have text for this exact like line. So it'll say, instead of just a dimly lit room, it'll say, you're in a dimly lit room, there is a sword in the corner. And then you'll know, okay, well that means that the sword item is in this room, so I'm gonna go pick that up. So that's basically what I'm working on. Stacey? Just so that
what I'm working on is to turn the code into the constant to make the code easier to understand and implement. And I think my further work is to build a map to make the architecture more easy for players to see and understand where it is and implement some objects to make the game more fun and easier to work on.
So what I was doing, so we wanted to, for example, if you were to input something like grab item or take item, so whether you use grab or take, we like the game would understand it as valid input. So like a little synonym system. Zach found a little thing called the iDictionary. So I was trying to implement, so when it received the input, if it didn't find the input as in the list of recognized commands, it would then generate a list of synonyms for that input, and then check if any of those synonyms are in the list of recognized commands. But then when we saw that like this dictionary in particular, there might be a better one out there, that like it produced like 5 synonyms, and they were like, for grab, for example, the words were like seize or capture. It was like just weird words. And
you think take would be in there? I guess not.
It wasn't. And so like I found that it was just better to like just hard code it. So in the end, instead of having something fancy like that, it's like hard code with different options, like things that make sense. And also our input as it stands, it's a bunch of if statements with all the commands. So if you find this, this or that, do this. I want to organize it into like a dictionary system. So dictionaries, the keys in the dictionary are recognized commands, and then those recognized commands, they lead to a message that she was talking about that she was standardizing. Because we had like numbers like 1, 2, 3, 4, and it gets kind of confusing. Because like, oh, I use 12 already for this, so like the standardized for messages, naming messages. So yeah, you just found that you just hard code like several different keys to lead to the same message. And that's just been separate.
So I kind of touched upon a little bit already what I said I was doing, but this diagram actually illustrates how it would work. So, not like that. Oh no. Let's hold it, all right. So the assets are the content of the game itself. So if you wanted to create your own game, the assets are what you would have to create for yourself. What we will supply is the architecture, which is input to update to output. So as you can see, the user is the input. They supply the input through the console, so it reads it as a text string in, but the user doesn't interact with the assets at all. So if you wanted to do something with an item, you can't interact with it directly. What we have to do is we have to be able to parse the input and see if the update class itself can do what we believe the user is intending. So that's what we're working on there. And then if it's successful, we'll pass it to output, and that's what the user will actually see as text.
Yeah, and really quickly what I'm working on is I'm just saving whatever's in the assets, making it so that you can save state in a JSON format. Yeah.
All right, just, it seems like it's coming out every 3 seconds. Just you can see it in a brief amount of time. Do we have access to the terminal? Okay, well, I think we're probably at about 5 minutes. Yes. Maybe that's, all right, cool. Yeah, I guess we're gonna have to cut it there. But if you guys want to see it, we can give you an example later. So yeah.
Okay, high frequency trading. Do you guys have slides, or did you send me your slides?
Alright, so our group is high frequency trading. Alright, so our goal is to create a program to decide whether or not you should buy or sell a given stock. There, we're going to be using real-time data from Alpha Vantage API. So it's an API that you can get. It'll just feed us information in JSON format that we can then take and then get values such as how well the stock is doing and over the course of a period of time. And then we plan on using several different algorithms, taking different points of the data that we get from the Alpha Vintage API, and then applying that and then comparing the results to decide whether or not we should buy or sell a given stock.
So here is our current algorithm, which we have spent most of our time on. Because this API doesn't provide real-time data, it only provides 1 minute interval of data. So we couldn't really rely on high speed, so we rely on the technical analysis instead of the high speed or high volume trading. And here I presented 2 lines, which is the 10-day average and 20-day average for the Starbucks in the recent 20 days. We just find the point where the 2 lines crosses. For example, we see the one cross point here where the 10 days average passed the 20 days average, and this is a buy signal. As we can see, the stocks go right up there. And here it crosses again where the 10 days average passes the 20-day average. And now this is a sell signal, so we see the price drops. And this is basically how the current algorithm works. And now we will adjust the average days. For example, this is the 20 and 10 days. We could, based on minutes or based on several weeks, depending on how long we are going to hold the stock.
So our progress so far is just working on the current algorithm, like Elvis just said, because we spent a lot of time on the API stuff. The API we're using is Alpha Advantage, which is a very powerful API, and we can get a lot of information from it. So we spent a lot of time on implementing and learning how to use the API, and we definitely met some difficulties like this. Because everybody is using different operating systems in this group. So for example, for me, I'm using Windows, but they are using Mac, and so it's kind of sometimes really hard for the PM to help me. So so for myself, I installed the VirtualBox and then the Ubuntu in it, so that I can work on the file and same way they are using the terminal. And so next we're definitely going to complete our algorithm, and so maybe in the future we can present the things and make it accessible for everybody to use it.
There's a lot of techniques that we've learned and implemented in our project so far. We've been, well, at least me personally, we've learned how to program through different text editors and scripts, and using different platforms for that. We've also learned how to find and implement an API, which has helped us with a bunch of different things. Obviously, we use Alpha Advantage, and we learned how to obtain the data through the API and then turn it into something that we can actually implement to implement an algorithm as well, and use that to find how we should trade and buy stocks. And we've also learned how to use GitHub and collaboration with other people, like actually pulling something from the master and pushing it back, and using that to implement our algorithms too.
So that's our
Okay, can music notes come up here? And then Python music changing app is next.
Okay, so our project was initially called Music Notes, but we changed our name because it was dumb. So now it's called Cadenza, which is, it's like a solo improvisation, and it's supposed to show off your virtuoso ability. So, trying to get some good vibes. How do I change this? So, the goals of our project are to have real-time online creation and editing of scores, so like music scores. So if any of you guys have ever used MuseScores or something like that, but posted online. We want an ergonomic, well-organized user interface and Google Docs style collaborative functionality. So that's the really important part of this project.
So our current progress so far would be we have the front end pretty much done. We have the main user interface, so creating a new score, so entering all the information regarding that. We also have our login settings and database set up, so ideally what we want to have to do is people can save scores and pieces that they've created and log in, edit them, create new ones, possibly share them in the future. And here are just some snippets of the CSS and HTML that we've used to create the, this is for like the main user interface.
And just to show you the login database before some of the code behind that. So we are using Flask to implement the web page, I guess. So that's just some of the Flask code behind the home page, and then some of the HTML and CSS for the login page. And so it's just a slide showing some of the new technologies that we're learning how to use. So, yeah, so as I said before, we're using Flask and HTML, CSS for the front end of the web page. And
these things, it's a kind of flat page, so it's hard like to work and kind of like simply merge it together. So we're using like GitHub to merge our repository and like making commands and assign jobs to chambers, like everything. And also we are looking into some Python packages which will like help us to build up some like feature, like analyze smoothly data and stuff like that. We're kind of looking into Midpoint and Midpoint 1 now.
And finally, some of the challenges that we're having, we're figuring out how to use GitHub. That was fun. Not still all the way there, but we're getting there. Also, learning how to like collaboratively code, like that was a new experience for me at least. Like I know how to like split up a group project, but splitting up the web page was like a little bit different. And another challenge that we actually had was like figuring out what kind of existing technology we wanted to integrate into our project. So we had to go through a lot of trial and error to figure out what kind of music rendering software we wanted to use. That was also a challenge.
And another thing that we're currently figuring out is, I guess, how to model it based off of like how Google Docs runs like the implementation of the collaborative aspect of the project, so like what it's supposed to be. So we'll probably be looking at more so how Google Docs is working and go off from there.
Challenge where it's most likely implementation of collaboration, which like enable everybody to like have it on the same page.
Okay, Python music changing app, and then wildcard 1 is after that.
Hey everyone, my name is Adi.
My name is Howard.
We are the Python music changing app. If you have a better name, honestly throw it our way because we're kind of working on it right now. But so far, if you don't know already, what we're trying to do is create like a more social atmosphere to music. What we're trying to do, right, is kind of create like a messaging kind of interface where people can create communities and vote on music so they can listen to it together. So kind of like what's going on in this picture, you can add new songs to your community, and then people in your community can vote on them, and whatever has the most votes at the current time will start playing. And then after that song starts playing, whatever next song has the most votes will just keep playing, and then just keep going like that. And what we have right now is, our database schema basically developed. We can handle basic queries. We can store members, like users, and their votes in the music. We're using Python, of course. We're using SQLite for our database implementation, and then Flask for our front end.
Yeah, I'm working on the front end. And right now we are using HTML and CSS to build basic structure. Like we're trying to implement an MP3 music player on the web page. And then we are going to add some more new features, maybe counting the minutes that you listen to the music every day, or anything that will happen on the normal MP3 website player like Spotify.
So things we learned, right, is basically using SQL or SQL, which is a structured query language, if you don't know that. Basic web development using Flask, and then effectively collaborating using GitHub, right? And then one thing we came across that we really don't know how to handle is getting Spotify premium access for the API, because if you want to get like all the songs, you need to have premium membership, and if you don't have that, then we might not be able to give you that option of using the application. So we're trying to get around that somehow.
Yeah, once we get around the API with Spotify access, we can just play the music. So this is basically a music playing website, and we are expecting to work on that. So
yeah, so our next step is basically implementing the Spotify API, linking the front end and the back end. If you showed the tutorial, right? Or not? Can we show that? Okay. Well, we have a demo, but we can't show it, unfortunately. And then right now we're working on a web page, but in the future maybe potentially a mobile application for better accessibility and then wider audiences. Maybe on iOS or Android. So, well, that's pretty much it. If you have any questions, please let us know. Well, thank you.
Okay, if we can have wildcard 1 come up, and then wildcard 2 is after that.
Well, this is kind of sad. This is not going to happen in the future. But what the idea is for our project was to take Twitter sentiments that are live on Twitter at the current moment from influential individuals such as Donald Trump and such investors that seem to have a strong hold in the
play out of the stock market, take their sentiment scores and plot them for different companies like this along with current stock data, which helps people who don't quite understand that much about the stock market or can't do that research on their own have a better investment idea for the future. So, whoa, let's see, yes.
Alright, so this is one of the example pages that we have. In the future, we plan on hopefully including more stocks. I think the general goal is the S&P 500, but right now we just have a couple examples. So right now, I guess the two major parts of the project are A, pulling the stock data, and we also use AlphaVantage. That's the top stock chart, and then also plotting the sentiment values, both from Twitter. So I'll talk about stock stuff right now. Right now it plots daily, the daily prices at the open mark. And I think in the future a good plan would be to, if you notice when I first clicked on the link it took a little bit to load. I want to figure out why it does that as well as what I can do to not make it so ugly in the future. And then I think also finding a way to plot this minute by minute, as well as pull like live data from AlphaVantage. I think that would be helpful in the future. Besides that, just making it look better in general. I have a lot of CSS work to do.
Okay, and then as far as Twitter sentiment scores, what I did was I used the Twitter or TweetViews API and used that along with some of my own code in order to pull data off of Twitter and just generally run it through a sentiment analysis toolkit and try to use that to find trends, and we've been plotting that there to try to hopefully find a correlation between like the general trends of Twitter sentiment, and hopefully later on we're going to progressively make that more and more representative of like stock prices. So something I'll be trying to do in the future is work with the values we have in our toolkit and hopefully tweak those values in order to get a more accurate representation for the graphs and like have this be more predictive of what's happening in the stock market. Like you can see, we've kind of got this trend here which somewhat matches that trend, but at the same time there are also areas that have almost no correlation, so ideally we would try to like refine our algorithm and our values in order to get this graph to more closely replicate the actual graph of the stock market, and that way we can use it for more useful things, because otherwise it doesn't really do much.
Yeah, just to expand on his part a little bit more, I was also, so he has his data points that he collects using an API, and I am in charge of taking that and turning those into CSVs, and from there we take those CSVs from within Excel and we create graphs based off his data points and his data frame. So this is a pretty basic version of our graphs currently, but it's just representative of the recent couple of days of data that we've received. And in the future, we would just like to expand upon these graphs a little bit more and make them more interactive and provide more data.
So in addition to everything that the team has said so far, one of the last things from a visual standpoint that we hope to achieve after discovering this do problem is making sure that no matter what platform you're viewing it on, the format stays relatively the same and looks relatively correct and nice. And also these graphs right here, at the moment, they don't necessarily do anything, but in the future they're going to be little windows into a live feed of how the stock is changing at the moment and how the Twitter API is showing the different sentiments on a daily basis. So you don't have to click so many links to get to that.
Come up.
what we're trying to do is
what we're trying to do is a game. Basically, it's a room break game. So my job is to create different maps and integrate those different maps into one whole. So and set those traps and the ending point and the starting point, and when it fails, how it go back to the starting points and try it again. So let me just show a quick demo of what I did. So this is just a demo, and it didn't be processed. So it haven't been processed by the graph. So which is what he did. So it's just this is a WASI. This is also we will replace those circles with something like maybe ghosts. I don't know. So we will just let me quick. So this is what I basically did. So totally the map, and let me so that's all I did. So but this is just a demo. So I already created the other 9 map, and now I'm trying to figure out how to integrate all of them into one whole map. So that is basically what I will do next. So.
And my part is to figure out the movements problems, but because our code did not merge up totally, so I need to use my computer to show the demo. So you can see that basically I just assign the key on the keyboard with the movements on the image, and about the background, just use the for a loop to change the RGB channel of the color. So that's.
So my job is to deal with those objects you saw in these demos, like the walls and obstacles. Like our previous plan is to make like a horror game, and you can move the camera around and you can move your character around, and yeah. But now we decided to simplify it a little bit. So my previous work is to figure out how to move your camera around, and now it's trying to like actually implement those obstacles. We'll have different obstacles and we'll have different effects.
So what we try to do next is I integrate my 9 maps into one whole. So and we haven't done the if it's punch some of the obstacles, how it appears feel, and how we have to put it back to the starting points. So that is what we try to figure out next, and also, and that's all. Thank you.
Okay, so our last group is the water bottle sensor project. Okay. Did you send me the slides or? Okay. When did you send them?
Yes.
Our project is a water bottle sensor project. So it was originally called fluid sensor, but it's kind of just like the worst. So we're calling it FLDZ for now until we come up with a better name. And then the goal is just to record and remind people about water intake, especially because every person has like an individualized amount of water they should be drinking versus like the random 64 number. It's an iOS application. And then so far I've worked on the login screen and registration. So that's what it looks like right now. And then I designed the logo. And then Jenny is not here today, but she is working on doing a Touch ID sort of thing, so you don't have to log in with your password.
So I'm in charge of all the backends. So yeah, progress so far, we've been using React Native for the design. So we got the interaction using JSX, navigation between screens and calculation, all using React Native, and using the online database using Firebase. Yeah, so it will keep the, it will handle all the signups and the logins and everything. So, all right. So as I mentioned, we are using React Native, so that's a new language for me. It was kind of tough to learn, but it works. We were using Node as well, which means we were using lots of other people's library. Looking for those is also a challenge. As I mentioned, we're using Firebase, and we learned how to a little bit use the terminal. And most of the time, the hard part is finding resources. So like reading all the documentations. It's kind of challenging as well. And yeah, roadblocks, challenges, learning without teachers is tough. It takes time and discipline, I guess. And teamwork is very hard. Yeah, I guess that's it. I don't, the demo is my laptop. I don't think, should we show? Oh yeah, I have some more. Oh yeah, this is how the Firebase database will look like. It's hassle to learn. This is the React Native code. Yeah. It's based, it has like different states. It's like React, but it can be used for both iOS and Android. For now, I haven't used any platform-specific codes, so it actually will work on both Android and iOS. So I guess that's better than just iOS. All right, that's it. Yes, just really quick. I didn't know this existed before, so adding Touch ID for the person that's not here. Animation, more just make it prettier. I guess it's good. And reward system, just for the later stuff. Yep, that's it. Thanks.
Okay, before everybody flees this room, if you lasted this long and you're still here, we have extra credit for you. So if you go on Relate, you should get that extra credit question, get some points.